Okay, now what we're going to do is look at dividing the complex numbers. But before we start an example of that, you need to understand what a complex conjugate is. Okay, the a plus bi, the a minus bi, those are representing what would be called complex conjugates. So if you notice, the only difference in these two is that you have the sign in the middle that's different. Now, not both signs are not different. Like the a is still a. It's going to be the sign that's in front of the imaginary part, which when they're written in the correct order will be the middle sign. So this is what a complex conjugate is. So what I have here is just some examples. So if my complex number is 5 plus 2i, then its conjugate is going to be 5 minus 2i. Okay? So then if I have 7 minus 3i, its complex conjugate is 7 plus 3i. Now, if all I have is just the imaginary part, and again, I pointed out to you, it's actually the sign that's in front of the imaginary part that we change each time. So the sign that I have in front of my imaginary part here, like in this case, would be an understood plus sign since it's positive. So that means the complex conjugate would have to be a negative 6i. Like in that case, it almost looks like you're just doing an opposite, okay? Now, this statement is actually telling you the process that you're going to use whenever we do the dividing. So you have to multiply the numerator and the denominator by the complex conjugate of the denominator. Okay, so if you forget, which one am I supposed to do the complex conjugate of, the one you do the complex conjugate of is going to be the part that's in the denominator. Okay, so here's our first example. Okay, so we have 6 divided by 3 minus 5i. Okay, so my complex conjugate. You want the complex conjugate of what you have in your denominator. So since this is 3 minus 5i, that means you want 3 plus 5i. And what you're told is you're going to multiply the numerator and the denominator by this complex conjugate. Okay, so it's just multiplying fractions. So you multiply across the top, you multiply across the bottom. Now, multiplying across the top is just going to require distributive property. So you just need to take your 6 and multiply it times both terms. So I would have 6 times 3, which is 18, and then the 6 times the 5i, so that's going to give me 30i. Now, when you go to multiply the denominators out, this is going to require the FOIL method, just like I used a while ago. So I've got to take the 3 times both of these terms, and then do the negative 5i times both of these terms. Okay, so starting with the 3, 3 times 3 is 9. 3 times 5i is 15i. Negative 5i times 3 is negative 15i. And then negative 5i times a positive 5i is a negative 25i squared. Okay, now there's some simplifying that we've got to do in the denominator. So the numerator is not going to change at this point because I can't actually add these terms together. They're not like terms. Okay, so I've got my 9. Now when you go to combine your terms that you have in the middle, they're going to add out. And if you're doing this process here correctly, these two are supposed to add out each time when you're doing this dividing process. Okay, so then I've got minus 25, and just like a while ago, I've got an I squared. I'm going to have to replace the I squared with negative 1. Okay, so that means now in my denominator, since this is negative 25 times negative 1, that would be the same as adding the 25, because a negative times a negative would be a positive. So this, add your two numbers on the bottom and you get a 34. Now I do have one more step I've got to go, but what's going to happen on these, of course when you've done your FOIL method back up here at the top, you have all these i's, but if you notice as I've gone through my steps, what I've ended up with in my denominator is just a real number. It's not going to have any i's in it. That's what's going to happen every single time in the denominator. You're going to be left with i's on the top possibly, but not on the bottom. All right, now the last step, what you need to do is actually separate this. Because when they say they want you to put the answer in A plus BI form, they want you to separate it so you've got your real part and you've got your imaginary part. So we're going to do the 18 over the 34. And then we're going to do the 30 over the 34. Then what will happen sometimes, not every time, you may end up with fractions that you can reduce. And I can reduce each of these by 2. So that's going to give me 9 over 17. Same thing here, I can reduce each of the 30 and the 34 by 2. So that's going to give me 15 over 17i. So this would be considered your answer for this particular problem. All right, let's look at one more dividing. Dividing's a little bit harder for you to catch on to. Like the adding, the subtracting was pretty easy. Multiplying's not that bad. Okay, so you're going to multiply the numerator and the denominator by the conjugate of what you have in your denominator. Now, I gave you an example of the conjugate of something like this a while ago. This is understood to have a plus sign in front of it because it's positive, so the conjugate would be a negative 4i. Okay, on the top, this is actually just the distributive property again. Now, it's in reverse order of what you're used to seeing, but you've got just this one term. Just take it and multiply it times each of these. So if I do negative 4i times the 8, I'm going to get negative 32i. And then negative 4i times the negative I is going to give me a positive 4i squared. Now on the bottom, this is just a term times a term. So the 4 times the negative 4 is going to give me negative 16. And the I times the I is going to give me I squared. Okay, what I've got to deal with actually in my numerator and my denominator both is I've got I squares. Okay, so just as we've already done a few times, you need to replace the I square with negative 1. Okay, so when I do my multiplication here, I'm going to get a negative 4. So, and I'm going to go ahead and write this down first. So the 4 times the negative 1 gives me negative 4. And then I'm going to subtract the 32i. So I just reversed the order again. Here I've got a negative 16 times a negative 1, so that's going to give me a positive 16. And now let's split it up like we just did. So I need to do the negative 4 over the 16. And then the 32 over the 16. And again, I've ended up with fractions that will reduce. Sometimes they will reduce, sometimes they won't. I can reduce each of my numbers here by 4. Now, of course, this is just going to be a whole number of 2, because 16 will go into 32 2 times. So this would be your answer for this one. Okay, so that's how you have to handle the dividing. And like I said, that's a little bit harder, so make sure you put a little bit more effort into practicing this. Okay, now actually just taking basically what we've already talked about, and on these problems you're just simply asked to simplify them, but especially on this first one, something that you would need to understand that you've got to do first. Okay, in each of these situations, if you notice, I've got negatives underneath my square root. Before I do anything else, I've got to deal with that negative underneath that square root. And that's something that we learned how to take care of back at the beginning. All right, so I'm going to bring down my 4. And what we learned to do is if there is a negative, we're going to separate it using a -1. Now, I'm not going to do anything with a 9 because 9's already a perfect square. Remember, if you go back to that list of numbers I gave you, 9 was on that list. All right, same thing here with the square root of the -49. And we'll separate the negative. Again, 49's on that list. It's a perfect square, so we're going to leave it like it is. Okay, so now the square root of the 9. Remember, that's what we did. We did the square root of each of those individually. Now, I took a step earlier where I physically wrote everything out individually, and I told you that you could just do it in your head. So do the square root of the 9, which is 3, and then the square root of the -1. Remember, that's what gave us the I. Okay, bring down your plus sign. Okay, square root of the 49 is 7. Square root of the -1 is I. So now I have a problem that looks just like the addition problem that I did earlier. Now that you have it in what they refer to as standard form, now you just combine like terms. So you combine your real numbers together. So the 4 plus the 6 is going to give us 10. And then combine your imaginary numbers together, or the imaginary parts. So 3 minus 7 is going to give me a -4i. So this is your answer. Okay, another example here. All right, so I don't have the square root of the negatives to deal with here, but see, I've got a combination of some multiplication and some addition. And it's just kind of like order of operations. You've got to take care of the multiplying before you can do the adding. So right here, I've got to apply the distributive property, and right here, I've got to apply the distributive property. So -5 times 1, -5 times 2i. Okay, so there's that one. Bring down your plus sign. Okay, distribute here. So 3i times 3 is going to give me 9i. And 3i times a -4i will give me -12i squared. All right, I've got to do a little bit of work right here before I need to do the addition, and that's because I've got the I squared. So if you notice on any problem that you come across an I squared, you have to replace it with a -1. We've done that on every problem that it's come up on so far. All right, so this first complex number is going to stay the same. So I'm going to replace, again, my I squared with -1. Okay, so what's going to happen is I multiply here, which is going to give me a +12. And I'm going to go ahead and write that term down first. And then I'm going to bring down the +9i. I'm just reversing the order, just to get it in that a plus bi form. Okay, so now I'm ready to combine my like terms. Okay, so combining our real parts together, that's going to give me a +7. And then combining my imaginary parts together, so -10 plus 9 is a -1i. So there's my final answer on that one.